Hello everyone, welcome to the second lecture. Basically, it will be the first lecture because earlier we saw only the introductory part of quantitative aptitude. So we covered what quantitative aptitude consists of. So as we saw, it consists of arithmetic ability as well as data interpretation. Now we are first going to study number system. That is the first topic which comes under arithmetic ability. Okay, so number system. So this is going to be our today's topic, number system. So first of all, let's study the fundamental concepts of number system. Then we'll be having one lecture which will be consisting of all the problems which will be asked from the topic number system. Okay. So first of all, what are numbers? Yeah. So for example, in Hindu Arabic system, we can say we have numbers which are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So these are all the numbers, and how can we forget the number 0? Yeah. So 0 plays an important role, as all we know. Basically, all the numbers play an important role in our life. Everything can be calculated, measured, as we know. Everything has numbers, right? Your phone number, it's a number. It consists of the combination of these numbers. Your bike or car's number, even if you're typing something or you're writing something, mostly numbers are also there, right? With respect to, as alphabets are important, similarly numbers are important. Okay, so you can say, what are these numbers? Basically you can count, right, on fingers. So now you can say that a number is a denoted by group of digits called as numerals. So number is denoted by group of digits, that is called as numeral. I hope this is visible. Okay, number is a group of digit. A number is denoted by a group of digits which are called as numerals. Okay, so for denoting a numeral, we can use the place value chart. So what is a place value chart? First of all, we will see that. Okay, to denote a number, we will use a place value chart. Now let's see. For example, you have a number over here, 315. Okay, so what basically is the places of these digits? You can divide into various place values for each number. That is, 5 is on the ones place, 1 is on the tens place, 3 is on the hundreds place. Okay, and so on. We might be having 1000 over here, then 10,000, yeah, and so on. Okay, so for example, if we go a bit further, 10,000 we have 100,000s. Okay, then we have lakhs, 10 lakhs, and so on. Okay, so over here 10 lakhs is nothing but 1 million also, you can say. So I will just fill up this number. We will make this number a bit larger. Suppose the number goes like 8, 2, 7, 3, 4. Okay, so now basically this is a number. This is a huge number, you can say. So what is the place value? So we have two concepts over here. First is the place value and second is the face value with respect to numbers. Yeah. So you can say, what is a place value and face value? So here we are going to study two topics, that is place value and face value. So here two definitions I can give. Face value is nothing but the number itself. Okay, it is nothing but the number itself. And the place value is, now only we explored, right? Ones, tens, hundreds, thousands, 10,000s, 100,000s, lakhs, and 10 lakhs. Okay, To make it simpler, what we can write it as, this will be 5. Okay, if we bring it here, it will be 10. Over here, it will be 300. Over here, it will be 4000. Similarly, over here, if you bring 3, it will be 30,000. 7 is brought over here. It will be 7 lakhs. So 100,000, yeah, correct. 30,000, then 7 lakhs. So 100,000 or lakhs you can also say. Similarly, yeah, lakhs over here. And then million, this is million you can say, and over here 10 lakhs. And this is 10 millions. And this is crore you can say, because yeah, 7 digit we have. So it is crore. Similarly, if we now bring over here the 2, so it will be how much? 20 lakhs. So we'll put this. So when you put the commas, it is easier to read. Okay. So over here, 50, so 5. Okay, 5 is at one's place. So what is the face value? Face value is always the number itself and place value. So these are the two things now we will study. Okay, so what is the place value? What is the face value? So face value is nothing but the number itself. Number itself. 3 over here, number itself. Again 4 is the face value. 3. Face means what is it is showing. Okay, we are irrespective of where it is lying in the number. Similarly over here we have 7 and here 2. Okay. Now if we go to the place value is, you can say, face value into the position where the number is. Okay. Simply to remember, I can give you this plain formula, face value into the place where number is. Okay. The place where number is nothing but ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on. Okay. So first of all, place value of 5 will be 5 into 1, that is 5. 1 is because of ones. Then for 1 we have 1 into 10, that is 10. So 10 is the place value. Similarly, for 3 into 100, it will be 300 is the place value. Similarly, what I want you guys to do is just fill out this in the comment section. So this is your question for today. Yeah, what will be the place value of this 4, 3, 7 and 2? Yes, 4,000, 30,000, 7 lakhs, 20 lakhs, and then 8 crore 20 lakhs. 8 can also you can take. Okay, so make it faster. Reply in the comments and just let's move towards the next topic. So we covered now place value and face value. So it is simple. Yeah. I hope you guys are understanding. If not, you can write what changes should I do. Should I increase the speed of teaching? Should I increase the font size? Should I change all the aspects? Yeah. Okay. So now let's move towards the next topic, that is nothing but various types of numbers. So we are studying now topic types of numbers. So we all might know what are the types of numbers. We all have studied this in our school life. Yes, but still this makes questions. Yeah, from this topic there are questions asked, and it will be easier if we brush up all the basics also. First we'll clear all the fundamental concepts and then we'll move towards the questions. So what are the types of numbers? So first I will write is natural number. Everyone might be knowing what are natural number. What are natural number? Natural number are the numbers simply can be stated as counting numbers. For example, 1, 2, 3, and so on, right? So natural numbers are the counting numbers. You can term them as counting numbers. Okay, which are 1, 2, 3, 4, 5, and so on. These are all counting numbers, nothing but natural numbers. Second, whole numbers. What are whole numbers? Whole numbers are natural numbers and adding 0 to that set. Okay, we can say whole numbers are 0 with natural numbers. So this is nothing but 0, 1, 2. Isn't it correct? Yeah. So these are whole numbers. It is basic. It is nothing. It is simple. Yeah. It is simple, as simple as possible I am making. Now let's move towards the third type of numbers. The third type of number is integers. So integers are nothing but, in simple form, I will give you the statement also. Natural numbers, or you can say whole numbers, set of whole numbers and negative natural numbers. Negative natural numbers. Okay, so whole numbers and negative natural numbers. We'll start from minus infinity, minus 3, minus 2, minus 1. We have 0 in between, 1, 2, 3, and so on. Yeah, so these are integers. Now let's move towards the another type of number, that is even numbers. What are even numbers? Even numbers are the numbers which are divisible by 2. So over here, divisible by 2. So what are these numbers? You can start with 2, 4, 6, 8, till infinity. Yes, any number that is divisible by 2 is nothing but an even number. Then let's move towards fifth type of numbers, that is odd numbers. What are odd numbers? Odd numbers are the numbers which are not even numbers. Yeah. Okay. So for example, also with even numbers there is one more thing. Yeah. That is 0 is also an even number. Remember this. Okay. 0 is also part of even number. And odd numbers are the numbers which are not even. So what is left? 1, 3, 4 is not odd, it is even. Then we will come towards 5. Similarly, 6 is not odd, it is even. Then 7, 9, 11, and so on till infinity. Okay, so I hope this is clear. Odd, even, integers, whole numbers, natural numbers. Now we will move towards another type of numbers, and those are prime numbers. So here this is fifth type. I will move towards sixth type. I hope this is clear. Okay, I am not blocking the. You can also once pause and check, take a screenshot. Okay, the sixth type is nothing but the prime numbers. So over here, so these are important numbers, okay, type of numbers. These are also, but most of the questions are made on prime numbers, co-prime numbers, composite numbers and all. Okay, let's see what exactly prime number means. So prime numbers are the numbers whose factors are strictly 1 and number itself. So remember this, the number whose factors are 1 and number itself. So you can directly say that 1 will be factor of any number, correct? In any number can come in one stable, in short, and number itself. So this is the deciding factor. The number itself should be the factor of that number and no other. Okay, only these two factors are there. Only these two. That is the condition. For example, let's see. Suppose I am considering a number 2. What are the factors of 2? It will come in one stable. So 1 is a factor. 2 stable. 2 will obviously come. This is a factor. In 3, can you number by any whole, multiply by any whole number that you will get again 2? No, it's not possible. So 3 is not. So you can see these two are factors, out of which 1 is there and second is the nothing but the number itself. Hence we can say 2 is a prime number. Similarly, one more example I will take. 3. 3 comes in one stable, 3 stable, not in 2 stable, not in 4, nothing. So this is also a prime number. 4. Let's take 4 as an example. It will come in one stable. It will come in 2 stable. Will it come in 3 stable? No. Will it come in 4 stable? Yes. So over here, 1 is factor. One condition met. The number itself is a factor. Second condition also met. So is it a prime? No, not at all. Why? Because 2 is not factor. Okay, 2 is a factor, but the condition says that either 1 or the number itself should be the factors. Then only you can claim it as a prime number. I hope it is clear. So now one more task for you guys. So I want you to write 20 prime numbers in the comment section in ascending order. Yeah, starting with 1 is there, 2 is there, 3 is there, yeah, and so on. Also, one more thing, 1 is not a prime number. Okay, so that is one thing that you should remember. Okay, it starts with 2, so 1 is the exception, you can say. So I hope till this it is clear. Prime numbers are also clear. We will be covering all the fundamentals first, then we will move towards the numericals and we'll cover slowly whole quantitative aptitude. This will be helpful, guys. Just keep focus, study. These are the simple topics, but when you come towards the question, the fundamentals will be helpful. On basis of fundamentals only, you will be able to solve all the problems and crack your respective exams and succeed in your life. So 6th type we covered. Now 7th type. 7th type is composite number. Composite numbers. So what are composite numbers? So basically, the numbers which are not prime numbers are composite numbers. Simply, if you put into the theory, the number which has factors as, you can say 1 is always there, the number itself and any other number. For example, with respect to composite numbers, okay, basically you can say which has more than two factors. These two are the condition. These two factors are, if there only these two factors are there, then it is a prime. But if there are more than, this is n, and n is not equal to 0, okay, then it is a composite number. Okay, the example are nothing but you can say the numbers which are not. For example, 2 is a prime, 3 is a prime. You can say 4 because 4 has 1, 2 and 4. Then 5 is a prime. Then 6 you can say that's 1, 2, 3 and 6. Then again 7 is a prime number. Then again composite 8 is a composite number. Why? Because 1, 2, then 4 and then 8 itself. Yeah. So these are the composite numbers. The second, what are the perfect numbers? So perfect numbers, the theory of perfect numbers is nothing but the number, the sum of whose factors except the number itself is equal to the number. Okay. For example, if I put it, sum of factors is equals to the number itself. The number whose sum of factors is nothing but equals to the number itself. Exception, sum of factors except 1 and except number itself. So when you add these factors, obviously the number itself will be the factor of its own, right? So you should not keep this in the here while summing it, and it should come to the number itself. For example, if you go, let's consider a number 4. What are the factors of 4? 1, 2 and 4, but we are excluding 4. So what is the sum? 3. Is it a perfect number? No, 4 is not perfect number. Okay. Let's consider 6. What are the factors? 1, 2, 3. And if we add 1 plus 2 plus 3, it will give you 6. Is it a perfect number? Yes, we got a perfect number. Yeah. Similarly, you can go to others also. For example, let's consider 28. Okay, some random number I am taking. 28. What will be the factors? 1, 2, 3 will come. No. 4. 4 will come. Will 4 come? No. 5, 6, 7. 4 sevens, right? So 4 is also there. 7 is also there. 8, 9, 10, 12, 11, 12, 13, 14 is there. 15, 16, 17, no. I guess that's it. And 28, right? So now, while summing, we should not consider 28. That is the definition of perfect numbers. So sum of factors except number itself while addition. So what will it come to? 1 plus 2 plus 4 plus 7 plus 40. It will come to 3 plus 4, that is again 7 plus 7 plus 14. This is 14 plus 14, 28. Correct? So 28 is also a perfect number. I hope it is clear with the examples. if you want, you can consider 3-4 examples as more. You just guys check for the number 36. That is one question, and let me know in the comment section that is it a perfect number or not. Yeah, is it a perfect number or not? Then another type of number that we will study is, after perfect number comes co-prime numbers or relative prime. Okay, co-prime or relative. So it's a simple definition. Suppose the two numbers should have HCF as 1. Okay, any two numbers whose HCF is 1 are co-prime or relative prime. Okay, it need not be that both the numbers should be prime. Okay, the HCF should be 1, highest common factor should be 1. So how it will be? Suppose you take 4 and 3. Obviously, what is the highest common factor? 1, right? For example, 9 and 14. What is the highest common factor? 1. So, are 4 and 3 co-prime or relatively prime? Yes, it is. Are 9 and 14 relatively prime or co-prime? Yes, because HCF is 1, right? Similarly, if you consider another example, 8 and 10. What is the HCF? It's 2. Are they co-prime? Not at all, because we want 1 to be the HCF. I hope this is clear. Just simple. Okay. Then we will move towards another topic or another type of numbers, and those are twin primes. So this is also interesting. Right over here. Twin primes. So what are twin prime numbers? So twin prime are nothing but the numbers whose difference is 2. Okay. So the two prime numbers whose difference is 2. That is the definition of twin primes. Two prime numbers whose difference equals to 2. So let's consider the examples. 2 is a prime number, 3 is a prime number. The difference is 1. Is it twin prime? No. 3 is a prime number, 5 is a prime number. The difference is 2. Is it twin prime? Yeah. Both are twin primes. Both are prime as well, and the difference is 2. Similarly, if you go ahead, 5 and 7. Are these two prime numbers? Yes. What is the difference? 2. Let me know in the comment section. Are these twin prime numbers? Yes or no? Yes. Similarly, you can consider various examples in the comment section. Okay, this I have already solved for 11 and 13. And I want 4 more pairs which are twin prime numbers. Okay. So this is your task for today. And then we have 2 important types of numbers. Okay. Now let's see what are those. So you might have heard rational numbers. Yes, guys. You might have heard rational numbers, rational numbers. Okay. So now rational numbers we'll study. This is 11th type of number, that is rational numbers. What are rational numbers? So basically, if you break them, or any number which can be written in the form of p by q. I will repeat once again. Rational numbers are the numbers which can be written in the form of p by q, okay, where p and q belong to integers. Both should be integers, and also one more condition, that is q should not be equal to 0. Simple as that. Rational numbers are the numbers which can be expressed in the form of p by q, and condition is that p and q should be integers and q should not be 0. So let's take an example. I will write an example. 2 can be written as 4 by 2. Is it a rational number? Yes, why not? 4 is an integer, q is an integer, 2 is an integer. So considering this as p, this as q, first condition is both should be integer, p and q. They are. The second is q should not be equal to 0, and it is not equal to 0. Therefore, we can say 4 by 2 is a rational number. Similarly, one more example. Is it a rational number? Minus 11, it is p and q is 3. Both are integers. One condition met. What is the second condition? Yeah, and the second condition is not equal to 0. This is also met. So this is also a rational number. Yes, I hope it is clear. You can write 3-4 examples and paste it into comment. Now we will move towards the 12th type of number, and it is also our last type of number, that is irrational numbers. Irrational number. Okay, and here one more R will be coming. Okay, irrational numbers. IRR. Rational numbers. Okay, irrational numbers. So what are irrational numbers? Basically the numbers which when expressed in decimal would be the non-terminating or non-repeating form. Okay, so when expressed in decimal, irrational numbers are the numbers when expressed in decimal. Yeah, when expressed in decimal would be non-terminating. Okay, and non-repeating. Okay, and the example goes up root 2. It should be non-terminating and non-repeating. Okay, similarly root 3. You can paste the values in the comment section. What is the value of root 3, root 2, root 5 and root 7? Okay, again what is the value of pi? Pi are the examples, epsilon. Okay, these are all the examples of irrational numbers. Okay, so you can take the screenshot. Sorry for this. After this, what we will cover is the facts of some numbers. Some facts are there. We'll just cover those facts and then we'll end up this lecture. I hope it is not getting more than 30 minutes. Okay. Yeah. So we'll now study some important facts. Important facts. So you should remember these facts. Important facts with respect to number system. So the first fact is I'll write it in red so you will remember it. So the first factor is all natural numbers are whole numbers. Is it true? Yes, because if we add natural numbers and 0, then it becomes whole number. Yes, 0 into subset of natural numbers, then it becomes whole number. So basically we can say it is fact true. It is fact, right? Second is all whole numbers are not natural numbers. Ulta of that. All whole are not what is happening are not natural numbers. This is the second fact. The third fact, even number plus even number gives even number. True? Example, 2 plus 6, 8, even plus even. You can explore more examples. But now we will cover this fact. In 3 only we will consider combinations. Even plus odd will give odd. Example, 4 plus 3, 7, odd. Yeah. Even minus odd is odd. Then odd plus odd is odd plus odd is even. Odd minus odd is even. So these are just combinations. You can try on your own also. I won't give much value to this, but remember, yeah, these are facts. Okay, simple. All the combinations. But okay, then let's not consider that as a fact. It's a simple logic. The smallest prime number is 2. It's a fact. Then the only even prime number, because after that everyone will be having factor 2, right? 4. Why not prime number? Because it has factor as 1, 4 and also 2. Only even prime number is 2. Okay. Then the first odd prime number is 3. Is a fact. So 1 is a unique number. Why? It is neither nor prime, neither composite. It's nor prime and neither composite. 7 fact. The least composite number is 4. Least composite number is 4. The least prime number was 2. Okay, and the composite is 4. Then one more fact is that the least odd composite number is 9, because let's see, after this composite 5 is not its prime. 6, no, it's okay, even and composite. And 7, no. So 9 will be there. Okay, 9 is the least composite odd number. Okay, so this was one thing. So what you can do is, we will stop this lecture over here and we'll go towards new problems. One more topic is there, that is test if the number is prime or not. Okay. So I will give heading as a test for a number to be prime. Test for a number to be prime. So what is the test? So let p be a given number and let n be the smallest counting number such that n square equals to p. Let p be a number and n be a smallest counting number such that n square is greater than or equal to p. This is a statement. Okay, let p be any number, n be any counting number, then n square is greater than or equal to p. Now test whether p is divisible by any of the prime numbers less than or equal to n. Okay, now we will have to check p is divisible by any prime number less than n. Yeah, and if yes, then p is not prime, otherwise p is prime. And if this condition is true, then it is prime. And if it is false, then it is not prime. Simple. Okay. If it is divisible, sorry for the mistake. If it is true, then it is not prime because it will be having extra factor, right? So let's consider an example. Yeah, we'll take example as 137. Okay, so this is our example which we are going to test with this test for number to be prime. With this theory, we are going to test whether 137 is a prime or not. So let's consider 137. What is the number that is like you can make into this format? So p we have is 137. So for example 12 we will take. What is, let's take n is equals to 12. Why you will get to know? Because the square of 12 will be 144. After that, if you go for 13, then 13 square is nothing but right 169. Yeah, huh. Okay, so but it's not. Yeah, it is greater than that. So n will be this. Thus we can write 12 square is greater than 137. Yeah, after that it will be, this is the least, right? If we go for n equals to 11, then it will be 121, which is lesser than this. What the theory says that n square, find n such that n square is greater than or equal to p. It's first n, right? The least, smallest n such that its square is greater than or equal to p. Now, the prime numbers less than 12 are. What are the prime numbers less than 12? Okay, p is divisible by any prime number less than n. So prime numbers less than 12 are 2, 3, 5, 7, 8, not 9, not 10, not, we have 11. Okay, so if this 137 is divisible by any of this number, if it is true, then it is not prime. If it is not divisible, then it is a prime. Is it divisible by 2? No. Why? It's not even at all. Divisible by 3. So for 3 we'll have to check rule of divisibility. What it says, that sum of the numbers should be divisible by 3. 3, 4, 4 plus 7, 11. Not at all. 5, you can say no. If we divide by 7, 7 ones are 3, 3, 6, 6, 7. Not at all. 11, 11 also not possible. Hence, I will declare this as a prime number. Is it true, guys? Let me know in the comment section. I am saying that 137 is a prime. Let me know whether it is or not. Yeah. We'll take one more example, that is 173. Okay. 173. For this you should remember the squares. Okay. So it will be helpful for you. So what I will take is greater than 173, the least value of n such that its square is greater than. So 14 I am taking, because if we take 14 as n, then 14 square will be nothing but it is, what is square of 14, guys? Let me know. Yeah, square of 14 is nothing but, let's check over here, 4 4 are 16, 1 5, and again 14, it is 196. Okay, so 196 is greater than 173, so we are meeting this criteria. Now the fact, prime numbers less than 14, is it divisible? Okay, now 14, for 14 what are there? 2 is there, 3 is there, then 5 is there, 7 is there, 11 is there, 13 is there. Okay, so is this 173 divisible by 2? Cancel. Is it divisible by 3? Cancel. 5? No. 7, if we check 14, and then how much? No. 11? Not at all. 13? Is it divisible by 13? No. So I am saying that 133 is also a prime number. 173, sorry. 173 is also a prime number. Okay. After this, we are going to discuss some important formulas, and then I will wrap it up. The session is becoming longer. Yeah. And then we will go to test of divisibility. In second part also it will be coming. This is part 1. Okay. Lecture 2A I will be putting it as of number system. Yeah. So these are whole numbers. Just remember, this is just to make you remind of that. Yeah, these are the numbers you are going to play with. Okay. Now the important formulas you all might be knowing. A plus B square is equals to A square plus B square plus 2AB. Okay. The second is A square plus B square can be also written as, this is only formula. The second is A plus B square plus A minus B square. A plus B square plus A minus B square is equals to 2A square plus B square. Why? Just use this first formula and let me know. Okay. Third. The third important formula is A minus B square is equals to A square minus 2AB plus B square. Okay. Using this and this formula, you can get the 2A square plus B square. Okay, let's move towards the fourth formula, that is separate. That is a plus b square minus a minus b square. Okay, just negative over here. Then it will give you 4ab. Then the fifth is nothing but a plus b square is equals to a plus b cube is equals to a cube plus b cube plus 3ab into a plus b. Now the sixth formula is a square minus b square is equals to a plus b into a minus b. Yeah. Then one more formula, a plus b plus c square. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, remember this. Now eighth formula is a cube plus b cube is equals to a plus b into a square plus b square, and it comes minus eb. Okay, one more formula is a cube plus b cube plus c cube minus 3abc. What this formula will give is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay, remember this formula. And one more thing is, so this is identity also, you can take it as a cube plus b cube plus c cube. If a plus b plus c is equals to 0, then comes into picture a cube plus b cube plus c cube is equals to 3abc. Okay, so these are 10 formulas. These are important formulas. Keep this into mind. This will be very much helpful for you guys. So I end here the session. I hope you guys liked it. Yeah, just take a snippet, and I hope you guys enjoy. This will be the number systems lecture 1. There will be one more part coming. After this, we will be covering the test of divisibilities, whether the number is divisible by 2 or not, 3 or not, some short tricks, some good examples. We will be solving some numericals also. Okay, so this was nothing but part 1, you can say, part 1. And today we covered what place value, face value, the types of numbers, then we covered some important facts, and then we covered some important formulae and how to detect whether a number is a prime or not. Okay, so a lot of topics we covered today. Thank you so much guys. Keep sharing the lectures if you feel these are helpful. Also give in comment like how you like the lecture. Give me feedback. I will try to improve as much as possible. I will bring good content to you guys, and also like, share and subscribe. Thank you.